Yeah. Good morning, good afternoon, and just in case I don't see you, good evening. This presentation introduces FlowUp, a mobile application designed to help users manage their daily tasks efficiently. Um, and the project was developed by Taylor Anthony Betanzos Rosas, Joseph Anthony Coman Larota, Jorge Enrique Contarrizo de Puma, Geraldine Marjorie Umasi Coila, and Carlos Joaquín Valdivia Luna. Flow in your daily task organized. My name is Joseph Kawana, and I will focus on explaining how uh, gener- generative AI tools were selected, compared, and applied during the development of this application. Okay. FlowUp is a native Android application designed to manage daily activities and tasks. It helps students organize academic work and personal activities by priority and due date. The app is built using Kotlin and Jetpack Compose, following Material Design tree principles to provide a modern and intuitive user interface. It includes local data storage, background processing, and reminder notifications to super effective time management. Okay. The initial tool selected for this project was GitHub Copilot. The choice was made to its direct integration with Android Studio and its ability to provide real-time code assistance during development. Uh, After this, a comparison was conducted between Cloud Sonnet for for mm, for 5, GPT 5.1, and Gemini 3 Pro. To why the AI a role-based prompt was used in instruction, it was expert Android developer. A single structure prompt defined the MVP, technical constraints, and deliverables. Yeah, GitHub Copilot was mainly used during implementation. Its advances include line call suggestions, context over recommendation, and based on sensitive files, response time of less that can 1 second during calling. Is made in suitable for implementation, refactoring, and maintaining developer productivity. Um, yeah, when comparing the models inside GitHub Copilot chat, clear difference were a server close net delivered delivered the weightless overall quality with average response time. Um, okay, 34.8 seconds. GPT 5.1 offered a balanced trade-off between quality and speed, around 44 seconds. Gemini Pro 3 Pro was a fastest model, 41 seconds, but provide less depth for Android and Jetpack Compose development. Um, in conclusion, although faster models were available, technical quality and architectural completeness were prioritized over response time. Generative AI was used as a development system, and a generate code was refined and adapted to the project requirements.
Hello everyone, in this part of the presentation I will explain how Hilt was integrated with navigation and the UI layer in the FlowUp project and how we evaluate and redefine the code generated by AI. Well, Here, in the navigation architecture, FlowUp uses Jetpack Compose navigation under a single activity architecture. All scripts are composable hosted inside a single nav host. Navigation is centralized in the FlowUp nav graph, while scripts are focused only on displaying the user interface. This helps keep the project structured and easy to maintain. In the navigation package, the navigation logic is organized in a dedicated navigation package. Navroutes.kt defines all routes as contains avoiding hardcode strings, and FlowUp navgraph configures the navigation graph and connects routes to the screens. The navigation host controller manages navigation state and the backstack. This design fully separates navigation from the UI layer. Navigations in the UI, well, UI screens do not use the nav controller directly. Instead, they receive navigation callbacks, for example, to navigate, to add, or edit an activity. This makes the UI reusable, testable, free from the navigation logic, and all navigation decisions remain centralized in the navigation graph. And Hilt integration, well, Hilt is used to manage dependencies across the app. Each screen obtains its view model using Hilt view model. Hilt Automatica creates view models, injects repositories, and manages their lifecycle. In short, navigation handles screens, Hilt handles dependencies, and the UI only consumes state. I prompt used to support architectural decisions. We use AI with the prompt. Why should I integrate Hill into my FlowUp project? The goal was to evaluate dependency injection in a modern Android app and compare Hill with alternatives like ViewModel Factory, Manual Singletons, and Coin. An evaluation of AI-generated code. It uses inject and heal view model properly and respect the MVVM architecture. It also aligned well with Jetpack Compose and navigation. From an architectural point of view, the solution met the technical requirements. Problem resolution, however, the AI did not generate the full Gradle and version catalog configuration. We encountered real issues such as conflict between KSP for Room and KAPT for Hilt. These problems were solved manually by correctly configuring the version catalog, plugins, and rebuilding the project. And in conclusion, it was very useful for architectural guidance and best practices, but human intervention was necessary to adapt the code to real project constraints. By combining AI assistance with technical review, we achieved a clean, scalable, and professional implementation of Hill in FlowUp.
Hi everybody, my name is Jorge Condorrios and I'm going to continue with the structure and the flow of our application. Okay, Flow Apps uses the MVVM architecture, separating UI, view model, and UI state for better organization. Okay, now we have our five screens. First one, home screen, shows pending and completed activities and allows users to complete, delete, and navigate to other screens. Second one, add activity. This is used to create new activities, while the third one, that is edit activity screen, allows editing existing ones using an activity ID. The fourth one is completed activity screen, displays only finished activities. And finally, we have the settings screen that lets users configure preferences like theme, notifications, and sorting their activities. Okay, now let's go with Help Me AI. We can see our files, no? Every we have three files per every screen. Okay, so we ask to ChatGPT why, no? Looking at the five FlowUp screens, I noticed that each component uses multiple files, exactly three. Would it be more efficient to group everything in one or two files? And what ChatGPT answers? Here we can see, yes, you can group everything, but however, using the screen plus view model plus UI state keeps responsibilities clearly separated. That makes the code easier to maintain. So if we can scale our application, it's going to be more easy if we have everything in different files. Second one, why coroutines are used. Here we can see a piece of code. Okay, the database operations. Room operations are suspend functions that must run in coroutines. Second one, reactive, reactive state. State flow and collect enable automatic UI updates when data change. Third one, lifecycle management. ViewModel scope auto-cancels coroutines when ViewModel is destroyed, preventing memory leaks. And fourth one, flow combination that combine operator observes multiple data source simultaneously. Let's go with the next part.
Hello, teacher and classmates. My name is Carlos Badilla, and I will continue with the project presentation. In this part, I was responsible for the local folder, which implements data processing using room database. The main goal of this layer is to store user activities locally and ensure the information is not lost when the application is crossed and the UI reacts automatically to data change. This folder contains three key components. Activity entity, which defines the table structure, activity DAO, which defines the data access operation, and app database, which centralizes database configuration and access. Read queries in the DAO return flow, allowing a room to emit new values whenever the database changes and keeping the URL active. However, mm, okay. However, combining a round flow and JPEG Compose introduces an important challenge, the correct use of the coroutines in the UI. Incorrect uses can cause unnecessary executations, UI blockade, or concurrence issues. To analyze these risks, we use generative AI. In this case, we use Crowded, and advanced prompts focused on really concurrent problems when using coroutines in the UI. The AI explained to the launching coroutines directly from composers is a bad practice. Since recomposition may trigger repeat execution and inconsistent states. It also confirmed the database operation should never run on the main thread, as this can cause UI freezes or any errors. Finally, it validates a concurrent architecture is the one used in our project. Run emits data via flow. The view model manager corrects user view model scopes. And the UI only observes the states with collect as states with life cycle without launching corrects directly. In this way, the AI was not only used to generate code, no, but also to validate critical technical decisions, ensuring safe concurrence and model under best practice. That's all. Thank you.
My name is Taylor Betanzos. In this project, part of the project, I focused on user preference persistence and the setting screens, which is where user define how they want the application to be have the option shows on the screen, such as notification, activity shortening, and the visual theme are stored using data store, which is the modern Android recommended is recommended solution for handling preference in a asynchronous and safe way. These preferences are stored in the data layer, specifically in data local preference, and are exposed as data flow. This allows any chance to be automatically reflected in the user interface without requirement additional logic. The settings screen is implemented, follow the MVVM patterns. The UI is only responsible for displaying the current state, while the view model manages updates and communicates with data store. During environment and AI tool was used as support to validate the architecture approved for, forever, and one objection to the initial response was that suggested a more complex architecture that necessary included additional layers that were not justified for MVP. For this reason, the final decision was a simplified implementation, getting a clear separation between UA and data, while avoiding over-engineering and prioritizing clarity, min- mm, minority, and alignment with the actual scope of the project. In conclusion, the solution ensures that the settings are persistent, reactive, and scalable, meeting for MVP requirement and following modern Android best practices. Continue. Now I will show a quick demonstration of the FlowUp application. The main goal of this app is create and manage tasks. First, I create a new task. I enter the task title and save. New save. Save. The task is now added to the list. Here in configuration, here I can change the task order. I can choose older first or newer first. The list is updates immediately and continue con theme selection. Now I change the application theme. I can switch become light mode and dark mode in the theme charms instantly. Notification. Here I active notification. I can test a notification to form it works. The notification is show is correctly. This option start background synchronization. The app can sync data without blocking the user. Finally, and can reset all settings to default. This restores the original configuration. In conclusion, FlowUp allows users to easily create tags and customize the app. Javier, thank you. Thank you.